In this video, I'm going to show you the many formulas that are associated with arithmetic sequences and geometric sequences. So let's say we have an arithmetic sequence of 3, 7, 11, 15, 19, and 23. Now, how do we know that this is an arithmetic sequence? Well, an arithmetic sequence is going to have a common difference. D is a symbol for that. So what the common difference is a consistent number that a sequence is being added by. So in this case, to go from 3 to 7, we'd have to add 4. We'd add 4. And to go from 7 to 11, we'd add 4 again. So this means our common difference is 4. Now, what if we wanted to find a term in this sequence that is maybe term 10? So this is term 1, this is term 2, this is term 3, 4, 5, 6, and these dots just represent the terms that come after term 6 to term 10, which is what we're going to attempt to find. So to find term 10, we'd use this formula. Tn is equal to T1 plus n minus 1 times d. Now n is the term number that we're trying to find, in this case 10, so Tn is equal to T1, which is 3, right here, plus n minus 1, so n is 10, times d, which is the common difference, 4. Let's simplify this down a bit. So 3 plus 9 times 4 is 36, so we get 39 is our 10th term in this sequence. Now, what if we wanted to find the sum of the first 10 terms in this sequence? Let me just write 39 here. That's term 10, so that we know. Okay, so to find the sum of the first 10 terms, we'd use this formula. Sn is equal to T1 plus Tn over 2 times n. So to find S10, we'd get the first term plus the 10th term, which is 39, divide that by 2 and times it by n, which is 10. So 3 plus 39 is 42, divide by 2, 21, times 10 is 210. So that's the sum of the first 10 terms of this sequence. But what if we wanted to find the sum of the first 10 terms, but we didn't know what the 10th term was? So let's say we have this sequence of 5, 10, 15, 20, 25. So this is our formula for calculating the sum of first n terms. But we could also change this formula so that we don't need to know the 10th term of the sequence. And it'd be as you can see, it looks pretty familiar with our other formula, Tn equals T1 plus n minus 1 times d. That's because we're just substituting this formula into here, and so it gives us this formula, which is pretty useful. So now let's try use it to calculate, let's say, the 20th term of this sequence. So S20 S20 is equal to 20 over 2 times 2 times 5 plus 20 minus 1 times our common difference, which is, to go from 5 to 10 is 5, 10 to 15 is also 5, so common difference is 5. So now we get 10 times 10 plus 19 times 5, which is, if you put that into your calculator, 10 plus 19 times 5 times 10 is 1050. So that's the sum of the first 20 terms using this formula. Okay, now let's talk about formulas associated with geometric sequences. So let's say we have this geometric sequence of 4, 8, 16, 32, and 64. How would we find the 7th term in this geometric sequence? Term 1, term 2, term 3, term 4, term 5. So we can use this formula, Tn equals T1 times Rn minus 1. This is basically the equivalent of Tn equals T1 plus n minus 1 times common difference. This is the equivalent of the arithmetic sequence formula. So we can use it to find the 7th term of this sequence. T7 equals 4 times the common ratio. R is the common ratio, which in this case you'd get by dividing term 2 by term 1. So it'd be 2. You could also get it by dividing term 3 by term 2, which is 2 again. So in this case the common ratio is 2. So 2 times 7 minus 1, so 4 times 2 to the 6, so it's 4 times 64, 2 to the 6 is 64, and 4 times 64 is 256. So that's term 7. Okay, now let's find the sum of the first 12 terms of this geometric sequence. To do that, we use this formula. Sn equals T1 times r to the n minus 1 over r minus 1. So if we want to find the first 12 terms, so if you want to find the sum of the first 12 terms of this geometric sequence, we'd have 4 times 2 to the 12 minus 1 over 2 minus 1. So 2 to the 12 is equal to 4096 minus 1 over 1. So it's basically 4 times 495 over 1. 4 times 4095 is this. So that's the sum of the first 12 terms of this geometric sequence. And you use this formula to get that. Okay, let's say if we had this sequence of 4, 2, 1, 1/2, and 1/4. And let's say it goes to infinity. How would we find this sum to infinity? Well, first of all, we need to check if a sum to infinity actually exists. And to do that, we get the absolute value of the common ratio and see if it's less than 1. If it's less than 1, a sum to infinity exists. However, if it's more, a sum to infinity does not exist. So let's calculate the common ratio of this geometric sequence right here. So 2 over 4 is 1/2. We can also check 1 over 2 is equal to 1/2. And so therefore our common ratio is 1/2. Now the absolute value of the common ratio would be, which is the absolute value of 1/2, it would be less than 1. The absolute value of 1/2 is just 1/2, and 1/2 is less than 1. So a sum to infinity does exist. Now to calculate this sum of infinity, we use this formula. T1 over 1 minus r is equal to the sum of infinity. So let's calculate it. 4 over 1 minus 1/2. And be 4 over minus 1/2. 4 over 1/2. Because 1 minus 1/2 is just 1/2. So 4 divided by 1/2 is 8. So the sum to infinity would be 8. And so, with that being said, let's do a review of all the formulas we've covered so far. So for arithmetic progressions or arithmetic sequences, we have the formula Tn equals T1 plus n minus 1 times d. We also have the sum of the first n terms is n over 2 T1 plus Tn over 2. And we also have another formula which is n over 2 times 2T1 plus n minus 1 times d. These two formulas can both be used. And for geometric progressions, we have this formula Tn equals T1 times r to the power of n minus 1, and to find the sum of the first n terms, it would be T1 times Rn minus 1 over R minus 1, and the sum to infinity for GPs would be T1 over 1 minus R, but this is only true if the absolute value of R is less than 1. So that's basically it. Thanks for watching.